So, for our slide, we are going to introduce the project organization, the statement of work, major milestone schedule, and budget schedule. And for our project, it is about a setting up a fully functional off-grid solar system for SK Punan Kluang as pioneer project by December 2025. As post-scope, it is to design and develop a fully functional off-grid system to power the whole school.
Hello, my name is Muhammad Mukul Bename and I will give introduction about the project. So first of all, the growing global demand for electricity and environmental concern related to conventional energy source have increased interest in sustainable alternatives such as off-grid solar energy. This project aims to establish an off-grid solar energy system for a primary school to provide a reliable, clean electricity source, addressing the school energy needs and promoting sustainable. By offering a stable power supply independent of a traditional grid, the project aims to mitigate the issues of power disruption and environmental impact associated with conventional energy. Additionally, the system will serve as an educational tool, fostering environmental awareness among students and staff, equipping them to tackle future environmental challenges.
Assalamualaikum. My name is Nur Fakhrul Razi. Now I'm going to present about project team organization. So first, as the project manager, which is Edric Bugin and Awang, the scope of project manager is oversees the entire project from planning to execution. Then ensure the project timeline and budget are fulfilled. Lastly, to serve as the primary connection between the project team and stakeholders. Next is technical leader, which is me. My job scope is to manage the technical development of the grid or of the off-grid solar system, then then collaborates with engineers and technicians on the design and implementations of the solar infrastructure. Lastly, to ensure the system fulfills the school energy demands and complies with safety regulations. Third, third is electrical engineer, which is Sri Sharvindran. The job scope is to design and develop the electrical component of the solar energy systems, handle wiring, voltage regulation and connection between solar panels, batteries and inverter, and lastly to ensure all electrical work meets established codes and safety standards. Then, for solar engineer, which is Muhammad Sufyan, the scope is specialized in the development of solar energy systems. Select the appropriate solar panels, batteries and inverter to meet the school's energy needs. Lastly, to optimize the system to achieve maximum efficiency and performance. Lastly, site manager, which is Muhammad Mukri, will supervise the on-site installation and construction activities, coordinate with local contractor to ensure compliance with project specifications, and lastly to manage logistics and resolve any issue that arise on site. That's all.
I'm going to explain about the statement of work SOW. There are five things that we are going to elaborate, such as objective, scope, project timeline, budget, and also project management. So for the first one, it is the objective. It is to achieve a long-term cost saving for the school by recurring or eliminating electricity bills, to integrate the solar energy system into the school curriculum. The next one is the scope, which is to install the solar energy system with minimal disruption to the school's operation, ensuring safety and adherence to local regulation. Train school staff on basic system operation and maintenance to ensure sustainability of the project. And the last scope is to conduct a comprehensive site assessment to determine the solar energy potential, including sunlight hours, roof space, and orientation. As for the project timeline, the project is expected to be finished by December 2025 with significant milestone defined along the way. As for the budget, a preliminary estimate might be in the range of 200,000 ringgit to 400,000 ringgit, but this is a subject to change based on the detailed design and local cost. And for the last one, it is for the project management. It is to assemble a project team with expertise in solar energy, electrical engineering, education, and project management. Develop a detailed project plan with milestone, deliverables, and resource allocation. Establish communication channel with all stakeholders, including school administrator, student, parent, and the local community.
Now, I'm going to present about work breakdown structure (WBS). First is project initiation, which is to establish the project scope, objective, and goals. Next, to develop a project charter that outlines the project goals and basic information. Lastly, to identify key stakeholders, including local government officials, educators, and school administrators. Next is site assessment and planning. Conduct a detailed site assessment to determine its solar potential and energy requirements. To develop a project plan that includes a budget estimate, schedule, and resource allocation. Lastly, to engage design teams to create detailed plans, including specification for the inverter, storage, and solar panel layout. Third is procurement and logistics, which is to identify and select supplier for solar equipment, batteries, and inverters. Arrange for the delivery and transportations of the components to the schools. Lastly, to purchase the necessary tools and supplies as outlined in the project plan. Fourth is the installation and the testing. To organize an installation team to set up the inverter, battery storage, and solar panels. Conduct through testing to ensure all system components are functioning correctly. And lastly, to address and resolve any issue discovered during testing to ensure a reliable off-grid solar energy system. And lastly, the training, documentation, and handover, which is to develop a training program for school staff on system operation and maintenance. Hand over the fully operational off-grid solar energy systems to school administrator and continue to offer support. And lastly, to provide comprehensive documentation, including system manuals and as-built record. That's all from. Thank you.
Hello, my name is Muhammad Sufyan and my matrix number is CN210114. Okay, I will explain a little bit about our Gantt chart project. Okay, as you can see, our Gantt chart is a 15-week project that typically includes a detailed timeline displaying various project tasks and our duration of dependencies. Each task is represented as a horizontal bar, as you can see. Uh, it's spanning each schedule time frame across the weeks. As you can see, for example, for each task, such as intimacy of project and requirement analysis, might span the first 2 weeks, followed by the site development and assessment. Next is purchasing and approval and permits. Uh, that could take up weeks 6 to 10. Uh, for the rest, tasks we do in weeks 11 to 15. All these tasks might be allocated to project deployment and review. The chart is also visually tracks progress, ensuring all the tasks are complete on time and highlighting any overlaps or dependencies between different activities.
Hi, I will focus on the resource schedule. The solar project schedule is organized into a detailed 12-week plan to ensure systematic implementation and the completion. So in the first 2 weeks, the project initiation and the planning phase begin with defining the project scope and objective, identifying stakeholders, establishing a communication plan, conducting a site assessment, and developing a comprehensive project plan with timelines and budget consideration. With week 3 and 4 are focused on procuring materials, where a list of required items for a solar installation is created. Quotations are obtained from suppliers, and necessary components like solar panels, battery, and inverters are selected and ordered to ensure their timely delivery. Site preparation occurs in week 5 and week 6, which involving the clearing of the installation site, setting up the foundation for solar panels, and installing a necessary safety measurement by constructing workers and electrician. For weeks 7 and 8, the solar panel installation take place. This includes assembling the panels, mounting them on the prepared foundation, connecting them to inverters and batteries, and the conducting functionality test. Following week 9 and 10, the focus shift to the installation of battery and inverters itself, where electrician handling the installation and connection to the solar and electrical system, followed by functionality test of the solar panel. And week 11 is dedicated to the system integration and testing of the project, where all the components of the solar energy system are integrated. Testing is conducted to ensure the system's proper functioning and all safety measures are verified and evaluated. And finally, in week 12, the project concludes by the training school staff on the use of maintenance of the solar system, documenting system operation and maintenance procedure, and officially handling over the completed project to the school.
Okay, next I will talk about our budget schedule. As you can see, we have 10 item description in here with a quantity that we need that we use in our project, including a unit cost and total cost. Okay, for the first one is a electrical device. Uh, For this one, we use five electrical device which cost 800 per device, which is the total cost is 4,000. Following by the controller of charge, the quantity is 1 and the unit cost is 600. Lighting features is quite many that we use. We use 10 and but it's more cheap than the electrical device which is only hundreds per units. So the total cost is 1,000. Next is battery preservation, which is battery housing. We use 4 and the total cost is 4,000 and 800. Next, the installation personnel, which is service. The service is cost 5,000 ringgit. Next is fees of for permits and inspection, which is also a service that costs 300 ringgit. Next, sun lighting panels and reversing. Actually, for reversing, we use one and the total cost is only 2,000. The sun lighting panels, we use 20, so the cost might be a little bit higher, which is 14,000. Okay. The connectors and wiring also a service that provide from the installation, which is the service is 900 ringgit. And lastly, the mounting framework, the costing for this item is 1,300 ringgit. Uh, for the reserve, I mean the 10% of the entire amount of the item is 3,450 ringgit. So the total project cost in all in all is 37,950 ringgit.
Okay, so the conclusion for this project is for by implementing an off-grid solar system energy system in the primary school can be significantly enhance the educational environment and promote sustainable by providing a reliable, conservative source of electricity for essential activity such as powering classroom, lighting, and electronic device. This renewable energy solution not only meets the school energy needs but also serves as an educational tool, teaching students about clean energy and environmental stewardship. Additionally, it reduces the school carbon footprint, fosters a sense of environmental responsibility, and ensures resilience against power outage, which is crucial for schools in remote areas. Overall, this initiative benefits the school and serves as a model for other institutions, encouraging the adoption of clean energy solutions for the sustainable future.